Our Hello World program is a very simple program. Let's see if we can make it somewhat more sophisticated. I'm going to introduce now the concept of variables. Watch as I add some lines of code to our Hello World program. Firstly, I'm just going to add one more line that looks like this. Printf, my age is 36. My age is 36, in case you're interested. And there it is, a fairly straightforward line that looks just like the previous one. My age is 36. Let's compile that. Fine, and run it. Hello world, my age is 36. Okay, excellent. Press enter, goes away. Now, that all works. That's all very straightforward. Let's look at the number 36. This program will always print the number 36. I think that's clear. It will print nothing but 36. So let's have a look and see if we can introduce a way that we can print an age that varies. Sometimes it's 36, sometimes it's 38, sometimes it's 12, sometimes it's 115. In other words, we want to introduce the concept of a variable. I'll do it like this. The first thing I'll do is go up to the previous line and add a line. Age equals 36 and a semicolon. Notice the number 36 is in blue. That's another function of the Dev C++ development environment. All numbers are displayed as blue. Nothing to worry about for you. So now we need to go and adjust this line, the printf line, such that it says something besides my age is 36. We want it to somehow go and get the age from here. I will tell you what this is in a minute. For now, I just want to get the program working. My age is... Now what I really want to say is somehow get it from the thing called age. And how do I do that? We've got a thing called age on the previous line. How do I somehow insert that in there? That's what I'm trying to do. And this is how I do it. I put a %d there, and then at the end I put age. So what happens is the printf function works like this. It says I print out the words my age is, and as soon as it sees a % sign it thinks, oh, hang on, I've got to go and examine a variable here. In particular, examining a %d. D stands for decimal, which means it's looking for a decimal number. It's not exactly what's going on, but it's close enough. Anyway, the decimal number that it goes to examine is this one over here called age, which has been set on the previous line to 36. So let's see if that works. I know that this is not going to work because I've deliberately omitted something, but let's see what happens anyway. Compile the project. 3 errors. Okay, let's have a look at those errors. Age undeclared. First use in this function. Okay, age is undeclared. That means that this thing here, this age here, is something that the compiler doesn't know about. It says, hang on, you're assigning 36 to this age, but what is the age? What is this thing called age that you're suddenly using? You haven't invented it anywhere. You must invent something before you can use it. The common word for inventing is declaring. So what we need to do is we need to declare age, and this is how we declare age. We go up to the top of the function. It's very important that you declare your variables at the top of the function, and we do it like this. int age, semicolon. That is the declaration of the variable called age. Furthermore, it declares age to be an int. What is an int? Well, if you don't know, int is short for integer, which means that age is now declared to be an integer. And if you don't know what an integer is, it's a whole number. It's a whole number that can be negative or 0 or positive, but it can't have any decimal component, can't have a fractional component. It's just a whole number. Now let's see if that compiles. Total errors 0. Excellent. Let's see if it runs. My age is 36. Now that doesn't look any different to how it was running before, but you'll notice that this time it's reading the age from the variable called age. So we've had our first examination of the use of variables. Now, for the people that absolutely have no idea what a variable is, who've never done programming before, here's a little conceptual overview of a variable. It's difficult to describe a variable. Technically, I guess they're small named pieces of memory that can be assigned values. The name, in particular, in this example that we've got, is the name called age. We have a variable that is named age. There's a piece of memory called age that can be assigned a value. And the value that we assigned this one is 36. So age is a very classic example of a variable. Now, if that doesn't make any sense to you, and it might not, then you can think about it like this. Oh, yes, of course, I should add, these values can change. Once you've assigned the value 36 to age, you can then go and assign some other value to age if you choose to. That's up to you, the programmer. That's why they're called variables, because their values can vary. Anyway, what I was going to say was, variables can be thought of boxes that can contain contents. So it's like you've got a box. Imagine a small box, a few inches around, and that box has a label on the front of it. The label is the name of the variable. The box is the variable, and the label on the front is the variable's name, and then you put things in the box. So imagine, getting back to our age variable, we've got a box, and the box is called age. And into that box we put the number 36. That's the way I like to think about it. Now, at some point we can take the value 36 out and put in some other value, or we can add things to the value 36. We can add another 3 and make it 39. And so the contents of the box vary with time. A brief note on variable names. I think it's important that everybody knows these things. Here's some rules regarding variable names. We've called our variable age. Okay, fair enough. Are there any rules deciding what you can and cannot call a variable? Yes, there are rules. Here's one of the rules. All variables must have unique names. You cannot have two variables that are both called age. Otherwise, the compiler won't know which is which. That is almost true. When we learn more about functions, you'll learn that there can be a variable called age in two different functions. But don't worry about that for the moment. Names can only contain the characters lowercase letters, uppercase letters, digits, and the underscore character. Don't think about using the dollar sign or the plus sign or anything like that. They are not allowed in C. Maybe in some other languages, but not C. Names must not begin with a digit. It means, obviously, that they can begin with anything else, but can't begin with a digit. Let's see what would happen if we tried to use a invalid name. For example, with our age variable, let's change the name of it to be called the 36 age. The 36 age. The 36 age. And let's see what happens if we try and compile that. Well, 23 errors. I'm sure there's not quite that many errors, but clearly it's not working. Non-digits in number and not hexadecimal. We've completely confused the compiler, and that's understandable. I wouldn't expect the compiler to know what's going on here. So let's just undo that and put it back the way it was. So clearly, variable names cannot begin with a digit. Let's see what happens if we can actually put any old digits somewhere else in the name of the variable. Age 36 is now the name of the variable. Age 36. 0 errors. Okay, so that worked fine as well. However, I don't want to call it age 36. That's a silly name for a variable because it implies that the age is always going to be 36 when we actually want to change it from time to time. Finally, there's another rule about variable names. They must not be longer than 31 characters. If you want to describe the variable, you have to do it in 31 characters or less. Now, some compilers will allow variable names that are longer than 31 characters. However, the first 31 characters of that name must be distinct. You can't have a variable name that looks like this. An extremely very long variable name 1 and an extremely very long variable name 2, and if the 1 and the 2 are beyond the 31 character point, then those two variables will be considered to be the same variable, which is certainly not what you want. Anyway, just don't even go down that road. Don't create variables that are that long. And a few more notes on the use of variables. We have discovered the int variable, the integer. There are actually many different types of variables, and we'll discover those in the next chapter. Just for now, be familiar with the term int. It's an important rule, a very important rule, that variables must be set before they can be read. That means you must put something into the box before you can try and find out what's in the box. This is commonly known as initialization. We have initialized the variable age to be 36. That is setting the variable. We have set the variable to 36. And then later, in the printf statement, we have a look at what's in the box and find that it's 36, so we print out 36. Clearly, you must put something into the box before you can find out what's in the box, but you'd be surprised as to how many programmers get this wrong so often, including me. Every programmer in the world is guilty of this. It is one of the most common bugs in computer programming. And that is forgetting to initialize your variable before you try and have a look what's in the variable. You might think, oh, well, that's obvious, I'd never try and do that. I promise you, you will. If you ever try and develop a proper C program, you will do this over and over and over again. And you will never learn. You'll still do it. You'll do it less, but you'll still do it. All I can do is warn you that you're going to do it. Let's look at what happens if you don't initialize a variable. Okay, here is the line that initializes the variable. Age equals 36. It's right here. So what happens if we delete that line? Okay, delete. Now we'll try and run the program without the variable age being initialized. Let's try and do that. Compile. Well, it still compiles without any errors. So you might think you haven't made any errors, but I promise you, you have, or rather, I have. Run the project. My age is 575. Now, why 575? Why not 0 or 36 or something else? Well, the answer is any variable that is not explicitly initialized will contain some random number. It's not like a random number generator. You recall that a variable is just a piece of memory. So when you set aside a piece of memory and give it a name, that memory will already have something in it, whether you think you've put something in there or not. The memory always has something in it. This piece of memory, age, happened to have the number 575 in it. Okay, fine. That's just the number that happened to be there. So I guess the term is not really, it's a random number, more like it's a number that you can't possibly know what it was. It could be anything, so we just call it a random number. Anyway, it's quite clear that you can see there is a danger in not initializing numbers. If it's just for the purpose of printing out the number, then, well, nothing particularly bad happens. But some variables are much more crucial to the correct running of the program than the variable that we just created, the age variable. And if a random number is inserted into that variable, then the program could quite easily crash. Anyway, that's enough on initializing variables. I'll put that line of code back into the program. Okay, age is 36. And we'll move on. The next rule of variable use is that variables are assigned values by use of the equals sign. Let's have a look at that. Okay, here is the equals sign, right here. And so we are putting the value into the box by use of the equals sign. We can do that again. Let's do some copying and pasting. And I'll prove to you that variables can actually vary. I'll copy those two lines, and I'll paste them here. This time I'll make my age 37, and we'll run that. So we should get 3 lines of output, an age of 36 followed by an age of 37. Let's see if that works. Compiled OK, no errors, and running. My age is 36, my age is 37. OK, excellent. Let's summarize what we know about variable declarations. Variables must be declared before they can be used. We've already seen that. We remember that we tried to compile the Hello World program before we had put the line at the top of the program saying int age, and it just didn't compile. So that rule is pretty obvious, and the compiler will pick you up if you don't do it. Also, you must declare variables at the top of a function. This means that you cannot arbitrarily declare a variable just before you're going to use it halfway down a function, you'll get a compiler error if you do. So just remember, if you get that error, to go and put the declaration back at the top of the function where it belongs. It's quite simple. Finally, let's just summarize how to declare a variable. You specify the type name, in this case integer, int, followed by the variable name, in this case age, followed by a semicolon. That concludes our discussion about variables.